question, we are essentially given a scenario where we have a capacitor of known capacitance that is connected to a battery, and then after that, that capacitor is taken out of the system where it is charged, and then after that, it is connected to another capacitor. And we have a little bit more information about what this first capacitor is going through from the question, but our ultimate goal is to figure out what the capacitance of C2 is equal to. So our first approach to this question is going to be looking at the first scenario in which we have our capacitor of known capacitance connected to a battery. So we know our capacitance, we also know our voltage, and so we're going to use this information and we're going to use the equation, which is capacitance is equal to charge over delta V, which is the change in voltage, to figure out what the charge in this entire system, this one over here, is. So, since we know what C is and we also know that delta V is 18 volts, we can simply just rearrange the equation and get C delta V is equal to Q, and then we're going to plug in our numbers and say that 7.25 times 18, which is 135 coulombs. Now we're going to kind of come back to what this number means in a little bit, but essentially you figured out how much charge there is on the plate once it's completely full. This is the total amount of charge that this plate can hold, and it is holding this amount of plate when it is being transferred from system 1 to system 2. So over here, originally in this plate, the capacitance is 130.5. Now the question tells us that the voltage drops to 8, and that's the only information that we are given. So what that tells us is that in the second scenario, our capacitance is still the same from what it was originally. The capacitor's capacitance does not change, it stays the same. We also know what the voltage is. It drops to 8 volts. So again, we can use the same thing. We're going to use the same equation as above, which is this one, and we're going to figure out how much charge the capacitor has in the second part of the question. So we would just simply put 7.25 times 8, which is 58 coulombs. We're going to revisit the idea that charge cannot be created or destroyed. So initially our capacitor had 130.5 coulombs of charge. We then put that capacitor into this system below, in which it is in parallel with another capacitor, and we figure out that after some time the charge on the first capacitor is 58 coulombs, which means that the rest of the charge is simply on this plate. So what we do is we subtract both of these numbers to figure out how much charge is on the second capacitor. So subtracting those two numbers gives us that there is 72.5 coulombs of charge on the second capacitor. So now that we have this number, we can now figure out kind of how much is the capacitance of the second capacitor. Before we start trying to understand how to figure out the capacitance of the second capacitor, we need to figure out that when it says that we put both of our capacitors, the first and the second one, in a single configuration, is that implying that our configuration is in parallel or series? And I forgot to completely draw this one through. But how do we figure out if what they're saying is that the two capacitors are in parallel or series? And there's a little hint in the question, which I've underlined in yellow, when it says that when equilibrium is reached, charges no longer flow. When our capacitors are in series, charge is constant. So there is no flow of charges from one plate to another. However, when our capacitors are in parallel, our charges, which are our electrons, flow and they go to the other plate. So this question tells you in kind of a hard way that our setup is in parallel. So now that we know that our configuration of our capacitors are in parallel, it's really quite simple to figure out what the capacitance is of the second capacitor. So we know that the charge on the second plate over here is 72.5, and we also know some rules related to capacitors when they are connected to each other in parallel, which is that the voltage is the same. So the voltage on this plate is equal to the voltage on the second plate. And the question tells us that the voltage on the first capacitor is 8. So that means that our voltage on the second one is also 8. So now we know Q, we know V. So now we can just use our equation and solve for our capacitance of the second capacitor, which would be 72.5 divided by 8, and that gives us 9.1 microfarads. And that's our final answer.